Section 1.6 is the heading is other types of equations. So the writer decided to put all the other types in one section. So let us see what are these other types of equations and how do we solve them. So the first kind is the rational equation. Keep in mind that when we hear the word rational, we think of a fraction. But what makes an equation a rational equation, let us come here and just talk about it. So if I say this is 1/2 x squared plus 2/3 x plus 5 equals 0. And if somebody thinks of asking, is this a rational equation? Just because I see a rational number here, it doesn't mean a rational equation. And the reason is, if you put this in a calculator, you're going to get 0.5, right? If you put this in the calculator, again, and this is the whole idea behind this, is you get 0.6 repeated, and so forth. And if you look at this equation, this is a quadratic equation. So let's talk about when we are deciding what type of equation, what is the key thing. The key thing is the x, is the variable. So when we're saying rational equation, then we're going to expect to see an x in the denominator. Okay? Just an example. You can still have x in the numerator. But the key thing is a rational, we call that expression. Okay, just keep that in mind. So let's look, first example I did it with you. So there's a bolded sentence here that you have to check your answer. This is the first kind of equations. We're gonna be exposed in this class to 3 different kinds of equations that we are required to check the answer as part of the solution, and this is the first kind. So since it's a rational equation and we have x in the denominator, we all know that we cannot divide by 0. So when we get an answer, we need to check to make sure that that answer doesn't make the denominator 0. So let us see. The idea, the main thing is how to solve is to find the least common denominator and then multiply the whole equation, and that means each term by the least common denominator. This way we get rid of the rational expression, and we'll see how we will have a nicer equation to work with. So let's look at this problem. So example 2, x over x minus 5 plus 5 equal 5 over x minus 5. So that's an easy one. There's only one denominator. Always specify what is your least common denominator. Now we're gonna, please don't skip this step. We're gonna multiply each term by the least common denominator. Each term, because we're multiplying the whole equation. Oops, minus. Okay. And what's nice about this is that this can make you get rid of the denominator, and now we have, let's see, only x plus 5x minus 25 is equal to 5. Let's try to solve this. Add like terms, 6x. Let's keep it on the right hand side since there's no x term. So 5 and plus 25, that makes it 30. Divide by 6 and you get that x is equal to 5. And again, we're not done here until we check. We check, what do we check? Not if it's gonna be the right answer or not. That's up to you if you want, but you check the denominator. Does this answer 5 makes the denominator 0? And in this case, absolutely. So this is not the answer. So this problem has no solution. Okay, some will have no solution, some will have only 1 out of 2, and some might have all none. Okay, let's look at others that the resulting equation is a quadratic. Okay, again, there's one done for you. Let's do one together. So first thing we do is we find the least common denominator. We have x plus 1 and x squared plus x. But if you think of the x squared plus x, take x as a common factor, and you will see that this term is none other than x times x plus 1. So the least common denominator, and keep it in factor form always. Do not multiply. Keep it in factor form. Now we're going to take this least common denominator and multiply each term again and again. Don't feel like, oh, I don't want to do that, it's too much work, I can do it in my head. People who do it in their head are the ones that are going to make a very common mistake. I'm not going to say what it is. Okay, each term by the least common denominator. And feel the reward. Actually, it feels good when you just get rid of the denominator. And now let's see what we have. 4x squared plus 3x plus 2x plus 2 is equal to 1. A quadratic equation. Let's add like terms. 3x and 2x, that's plus 5x. 2 minus 1 is plus 1 equals 0. We're going to try to factor. We always try to factor first. So 4x maybe times x, and 1 times 1. Everything is positive. So the outers are 4x, the inner is 1x. Add them up, and yes, it's equal to 5x. So now either 4x plus 1 equals 0, or 4x equal negative 1, or x is negative 1/4, or x plus 1 equals 0. In this case, x is equal to negative 1. So now we're going to check. Well, guess what? The negative 1, immediately in the first denominator, negative 1 plus 1, that's 0. That's not an answer. But the negative 1/4, again, I don't care about the value. All I care, does it make this 0? No. This 0? No. That's 0. So there's only one answer. Okay, so now let's look at the second type. Actually, it's here, which is radical equations. Keep in mind that when we say radical equations, that means there's a radical expression. And again, a radical expression is not having something like the square root of 2x squared plus the square root of 3x plus 2 equals 0. That's still a quadratic equation. So radical equations is when the variable is inside the radical. Okay? All right. There are steps to working these problems, and we're going to also encounter two kinds. The first kind is the kind that has only one radical in it, and the other one that has two radical. The whole idea is, here are the steps, is to isolate the radical term. Again, and you'll see other videos in my math lab that will explain all this also. So the first thing is to isolate the radicals. These radicals cannot be on the same side of the equation. Then you're going to raise both sides of the equation to a power equal to the index. What do we mean by index? The index is this. If there's nothing written, it's a square root. That's the third root, fourth root. This is called the index. Okay, and then we continue solving. So again, please look at the first example. I've done that with you, and I mean here, not with you, I've done it for you. Let's do example 6 together. So here's the first thing. We have x minus the square root of 15 minus 2x equals 0. The first step is important. Again, if you skip a step, not usually, you will not get the right answer. So the first thing is to isolate. So I don't know why okay, so x equal, and bring this to the right hand side. So it's going to be the square root of 15 minus 2x. We isolated the radical term. Now raise both sides of the equation to a power equal to the index. Well, the index is 2, so when you raise it, you raise it to the second power, and now we get x squared equal, this with square root squared cancel each other, we get 15 minus 2x. That's a quadratic equation. Put everything on one side of the equation, make it equal to 0, and try to solve. Again, we always try to factor first. I need factors of 15 that are different in sign. Since they're both x, I can put the sign immediately. And the difference has to be 2, so 5 times 3, and the bigger one is the positive. So let's check again. 5x minus 3x, that's 2x. So either x is equal to negative 5 or x is equal to the 3. Okay, so whatever I did not tell you, that again here we have to check the answer. Why do we have to check the answer? Because you might get something we call extraneous solution, or what we call a false solution. Where does it come from? Let me explain it before I continue. Let's say I started with x equal to 4. That's an equation. Now I want to raise both sides of the equation to the second power, squaring it. So it's x squared equal to 16. Now if I want to solve this quadratic equation using the square root property, x is plus or minus 4. So when we raise both sides of the equation, we might get, okay, let me make them separate here. So again, the solution is x equal plus or minus, meaning one time is plus 4, one time is minus 4. Well, this is the original equation, but I got some solution that is not part of my original equation. And that's what we call extraneous or false solution. So when we solve, when we raise both sides of the equation to an even power, we always have to check our answers. How do we check the answers? In the original equation. So here's the checking. You can do it in your head, you can write it down, it's up to you. So let's try negative 5. So I have negative 5 minus the square root of 15. Minus 5 times minus 2 is positive 10. Is that equal to 0? So let's see. Negative 5 minus the square root of 25. Again, it's all that question mark. So is negative 5 minus 5 equal to 0? Absolutely not. Equal to negative 10. Let's check the 3. I have 3 minus the square root of 15 minus 3 times 2 is 6. Is that equal to 0? 3 minus the square root of 9, is that equal to 0? 3 minus 3, is that equal to 0? Yes. So again, I need to see the check and the cross. That means you checked your work, you know that something is right or something is not right. Okay, so we've done that. We're gonna have more examples done again, another example done for you. I'm gonna do one more, and then we'll go to the 2 square roots. So the first step is to isolate the radical, leave it by itself. So we need to add the 5 to both sides of the equation. Now square both sides of the equation. When you square the square root, they just cancel each other. Now, let's again remember how to square the binomial. 3x squared is 9x squared. The sign is positive, twice the product of this 2. The 5 times 3x is 15, times 2 is 30x, plus 25. Again, this is a quadratic equation. Let's move everything to the right hand side. So we're going to subtract 3, that makes it 27. Subtract 7, that makes it 18, equals 0. Oh, nice. Everything is divisible by 3. Let's 9 actually. Everything is divisible by 9. So let's divide by 9. We get x squared plus 3x plus 2 equals 0. Try to factor. We get x and x, 2 times 1, plus and plus. So either, let's write it here. Either x is equal to negative 1 or x is equal to negative 2. Again, we're going to check my work. You can check it without writing it, whatever you want. Let's check the negative 1. The square root of. So negative 1 times 3, that's negative 3, and 7. 7 minus 3 is 4. That's too long. Square root of 4 minus 5, is that equal to 3 times negative 1, which is negative 3. So is 2 minus 5 equal negative 3? Absolutely. So that's an answer. Let's check the negative 2. The square root of, so 3 times negative 2 is negative 6, so this is the square root of 1 minus 5, is that equal to negative 6? So 1 minus 5, is that equal to negative 6? It's absolutely not. So we only have one solution. Okay, so now we're gonna look at, I gave you 2 to try. We're going to solve equations that have 2 radicals. The 2 radicals is the same idea. You have to isolate the radicals. Now we have 2 radicals. So each one has to be on a separate side to solve. Okay, so I'm going to do just one last example for this section with you, and then I'll give you one to try on your own. Again, read the one that I've done so far. So the first step is to isolate the radical. So we're going to have the square root of x plus 2 is equal to 2 minus the square root of 3x plus 4. Now we have to square both sides. So squaring a square root, you're going to get x plus 2 is equal to, again, squaring the binomial, guys. The first term squared is 4 minus twice the product of these 2. So let me write it here in details because this looks funny to some students. So again, it's 2ax. So negative 2 times this plus the second term squared. Let's see what we have. X plus 2 is equal to 4 minus 4 times the square root of 3x plus 4, plus when you square a square root, you get what's inside. Now we need to isolate the radical again. You see that we went back, so the 2 radicals are always going to get you back to the 1 radical. Since this is a negative, I personally like to put it on the left hand side to make it positive. So bring the term that has a radical on the left hand side. Now what do we have? We have 3x here minus x, that makes it 2x. We have a 4 plus 4, that's 8. 8 take away 2 is 6. Now we see that this is divisible by 2. So let's go ahead and divide by 2. So we're going to get 2, the square root of 3x plus 4 equal to x plus 3. Now listen carefully to this example. The term, the radical term, is isolated. This is one term. Remember what we talk about terms. What separate terms is plus and minus. So these are two terms, but this is one term. Okay, so the products makes it a term. So the term that has the radical is isolated. So now, of course, we can divide by 2, but oh my goodness, of course I won't deal with fractions. So leave it and square both sides of the equation. Now the only thing you need to remember is that when you square a product, so a times b, the whole thing squared, is a squared times b squared. So here we're going to have 4 times, when you square the square root, you're going to have 3x plus 4. Again, this comes from the fact that a times b squared is equal to a squared times b squared. So a product squared, you square each one. So I have a product squared, so it's 2 squared, which is 4, times the square root squared, which is what's inside. Let's square this binomial, so that's x squared plus twice the product of these two, so 6x plus 9. Let's continue. 12x plus 16 equal x squared plus 6x plus 9. It's a quadratic equation. Let's put everything on the right hand side. X squared, so 6x, take away 12, negative 6x. 9, take away 16, negative 7, equal to 0. To solve, you're going to factor first. Try factoring always. And now x times x, 7 times 1, and the bigger is the negative. Positive, check it, negative 7x, positive 1x makes this. So we have 2 answers to check. Either x is negative 1 or x is 7. Now the checking. I'm going to make this time more oral than writing it down. Let's check the negative 1. So 2 minus 1, that's 1. Square root of 1 is 1, plus 3 times negative 1 is negative 3. 4 take away 3 is 1. The square root of 1 is 1. Is 1 plus 1 equal 2? Absolutely. Let's check the 7. Square root of 7 plus 2, which is 9. Square root of 9 is 3, plus the square root of 7 times 3 is 21. Add 4 is 25. The square root of 25 is 5. Is 3 plus 5 equal to 2? No, it's not. So we only have one answer. Please, I'll let you try this on your own. I gave you the answers for you to check. All right.